The cosmos had rules. People believed so. But in the summer of 2025, that belief began to dissolve. An impossible visitor arrived from the void, and the laws of the universe, once written in stone, were suddenly cast in shadow. Hello, I'm Mike, the astronaut who will take you into sleep each night with cosmic hypotheses about the vast universe, based on real research here at Deep Space Documentary. Today, we are going to explore the mystery of Comet 3I Atlas. It is a wanderer from another star, an object that defies our neatest categories and forces us to ask terrifying questions about what truly drifts in the silent dark between worlds. Now, relax on your beloved bed, breathe gently, and get ready to board the spaceship with astronaut Mike for tonight's sleep voyage. But before we take off, if you enjoy my voice, please leave me a like and subscribe to the channel. And if you can, share your time and location in the comments below so I can know where my fellow astronauts are joining me from around the world. Now, let's begin our cosmic journey. Picture this: a ghostly atmosphere stretching 696,000 kilometers across the blackness of space. That is not the diameter of a star, nor a gas giant. It is the invisible envelope surrounding what might be the most extraordinary and perhaps unsettling visitor our solar system has received in all of human history. Right now, as you listen to these words, this object, Comet 3I Atlas, is racing toward the Sun, dragging behind it a carbon dioxide atmosphere so enormous it could swallow our entire star. The Spherex Observatory has mapped this spectral giant, revealing a coma, the technical term for a comet's fuzzy atmosphere, extending at least 348,000 kilometers in every single direction. Do the math, and you're looking at something roughly half the Sun's diameter in width. A structure so vast, it defies easy comprehension. But this is where the mystery truly begins, where the facts of science begin to blur into the unsettling realm of speculation. This isn't some blazing inferno you could spot with backyard binoculars. The comet's nucleus, its actual rocky and icy heart, remains frustratingly small and dim. Hubble's best estimates, peering through the glare, place it at no more than 5.6 kilometers across. That's smaller than Manhattan. Yet somehow, this cosmic pebble, this tiny, tumbling stone, is generating an atmosphere 55 times wider than the planet Earth itself. The question that's keeping astronomers awake at night is simple. How is this even possible? And the more unsettling question we must dare to ask is, what if it isn't entirely natural? What if this impossible scale is an illusion, a piece of cosmic stagecraft designed to be seen? To understand this visitor, we must understand its dual nature, its two faces, because how big Comet Atlas truly is depends entirely on how you look at it. In visible light, the same wavelengths our eyes evolved to detect, the comet appears as a fuzzy star, roughly 26,400 kilometers across. That's about 2 Earth diameters, impressive certainly, but a fairly typical size for an active comet. Ground-based telescopes capture this optical coma as a compact, relatively dense cloud of dust and gas, illuminated by the reflected light of our distant sun. But this is merely the first layer of the onion, the visible mask on an invisible entity. When we switch to near-infrared wavelengths, a feat accomplished by the powerful eyes of the JWST and Spherex, Atlas transforms into something utterly different. The comet becomes a gossamer envelope of carbon dioxide, stretching to its full, terrifying 696,000 kilometer diameter. Same comet, same moment in time, but an entirely different definition of size. It is a cosmic Russian doll. It's a fundamental physical reality. Different molecules emit and absorb light at different wavelengths. The optical coma traces dust and gases that interact with visible light. The infrared envelope reveals the carbon dioxide that glows brightly in thermal infrared, but remains utterly transparent to our eyes. This disconnect between visible and invisible scale should make us profoundly uncomfortable. It forces us to ask, how many other cosmic phenomena are we missing simply because we're looking in the wrong colors? How many other half-sun-wide atmospheres have drifted past our world unnoticed because they don't glow in the light our ancestors evolved to see? The universe we perceive is but a sliver of the one that truly exists. But let us push this thought further. What if this duality is not a coincidence of physics, but a deliberate design? In ancient folklore, powerful beings could cast a glamour, an enchantment to make something appear as something else, to make a castle look like a ruin, or a monster look like a harmless animal. Could we be witnessing a technological glamour on a cosmic scale? Consider the possibility that the tiny nucleus is not a simple rock, but a probe, a vessel, something artificial. Such an object would want to hide. By boiling off a specific compound like carbon dioxide, it could generate an enormous, yet almost entirely empty cloud around itself. To a primitive civilization, it would look like a comet, a natural, uninteresting, and certainly unthreatening phenomenon. The immense size would be a deterrent, its sheer scale making it seem like a natural wonder rather than a compact piece of technology. The perfect camouflage, the perfect disguise to drift through an inhabited system, observing without ever revealing its true nature. Or perhaps the purpose isn't to hide, but to communicate. What if the true message of Atlas is not the object itself, but the giant invisible structure it has built? Advanced civilizations might abandon noisy, inefficient radio waves for communication. Perhaps they write their messages on the fabric of space itself, creating temporary, massive structures that are only visible in specific, non-obvious wavelengths, like the infrared signature of carbon dioxide. We, with our new infrared telescopes, may have accidentally stumbled upon a signpost, a piece of a galactic conversation we were never meant to overhear. The visible comet could be nothing more than the pen, while the vast invisible cloud is the ink, writing a message in a language of molecular physics we are only just beginning to read. The question then becomes, what does the message say? Is its impossible chemistry a warning? Is its ancient origin a clue? We are like ants crawling over a smartphone, able to measure its heat and its size, but utterly oblivious to the complex information it contains. This visitor, this impossible spectacle, reveals a terrifying truth. The universe is not just what we see. It operates on scales and in dimensions that challenge our very perception of reality. And more unsettling still, it hints that what we perceive as natural phenomena, a simple comet, a distant star, might just be the surface layer of a much deeper and perhaps far more intelligent reality. Speed kills, they say. But in the case of 3I Atlas, speed reveals. This isn't just another comet lazily orbiting our sun like a cosmic commuter on a predictable schedule. Atlas is moving at 68 kilometers per second at its closest approach, a velocity so extreme it could cross the continental United States in less than 2 minutes. That is hyperfast by the standards of our solar system, and it tells us something extraordinary and absolute. This visitor will never return. The mathematics are as beautiful as they are unforgiving. Atlas follows what astronomers call a hyperbolic orbit, meaning it is gravitationally unbound from our solar system. It is a tourist, not a resident. Once it swings around our sun this October, it will accelerate back into the interstellar void, flung away by our star's gravity, never to be seen again by human eyes. In cosmic terms, we're witnessing a one-night stand between our solar system and a wanderer from elsewhere. But where is elsewhere exactly? When we trace its trajectory backward through space and time, we arrive at a startling conclusion. This comet originated from the direction of Sagittarius, near the galactic center. It's been cruising through the cold, silent dark for potentially billions of years, a ghost ship carrying the chemical fingerprints of a stellar neighborhood we will never see. The age estimates are staggering, pushing the boundaries of what we thought possible. Multiple kinematic analyses suggest 3 Atlas belongs to what astronomers call the thick disk population of our galaxy, ancient stars and debris whose orbital characteristics scream, "I was here first." Some studies bracket its age between 3 and 11 billion years. Let that settle for a moment. The rocky nucleus of Atlas, no bigger than a small city, may have formed when our own sun was nothing more than a diffuse cloud of gas and dust. It has watched our galaxy evolve through cosmic epochs we can barely imagine. It has survived stellar explosions, gravitational perturbations, and the slow, grinding churn of galactic dynamics that eventually ejected it from whatever system gave it birth. This is not a rock. This is a time capsule, an artifact, an emissary from an era when the rules of creation were different. And it is not the first. To truly grasp the significance of Atlas, we must see it not as an isolated event, but as the third act in a play that began in 2017. It is the third in a sequence of strange visitors, each one more perplexing than the last. First came Oumuamua, the astronomical equivalent of a whisper in a locked room. A cigar-shaped wanderer that showed no detectable coma, no gas, no tail, none of the behavior of a comet. Yet it accelerated away from the sun, pushed by a mysterious force that wasn't gravity. Was it a shard of exotic nitrogen ice, a fragment of a tidally disrupted world? Or was it, as some scientists dared to suggest, our first encounter with extraterrestrial technology? A solar sail, a derelict. Probe, tumbling end over end through our system. Oumuamua was the silent scout. It offered no explanation. It simply flew past, observed, and left us with a universe of unanswered questions. It was an anomaly, a single data point that could have been a fluke. Then, just 2 years later, came 2I Borisov. It arrived like a cosmic palate cleanser, behaving exactly as we expected an interstellar comet should. It had a coma, a tail, the familiar signature of a dirty snowball from space. Borisov restored our confidence, but it too carried a secret. Its chemistry was strange, rich in carbon monoxide, suggesting it formed in a place much colder than our own solar system. It was the normal visitor that was still distinctly alien. If Oumuamua was the silent scout sent to see if anyone was home, perhaps Borisov was the follow-up, a more conventional probe designed to look natural, to see how we would react. Would we notice it? Would we study it? It was a test, a way to gauge our technological maturity without revealing its own hand. And now we have Atlas. If the first 2 were probes, Atlas is the message. It is hyperactive, chemically impossible, and impossibly large. It combines the profound weirdness of Oumuamua with the cometary nature of Borisov, but amplifies both to an extreme. We must ask, if this is a deliberate sequence, what is the purpose of this third visitor? Perhaps its ancient origin is the key. A civilization that arose in the galaxy's youth, 10 or 11 billion years ago, would be unimaginably advanced, but it would also, by now, almost certainly be extinct. What would such a civilization do in its final moments? Perhaps it would launch arc ships, not of living beings, but of information. Time capsules containing their history, their science, their art, encoded into the very chemistry and structure of an object designed to last for eternity. The bizarre carbon dioxide ratio might not be a natural fluke. It could be a key, a primer that says, this object is artificial, look closer. Its trajectory, a grand tour of our solar system, could be its final act, delivering its data packet to a world it identified as potentially emergent. It is a message in a bottle from a dead civilization, delivered to our shore. Or consider a more poignant possibility. What if Atlas is a tomb, the final, wandering mausoleum of the last of a species? Its tiny nucleus could be a vessel, shielded by untold technology, carrying the last traces of a civilization's existence. The immense coma would not be camouflage, but a memorial, a funeral shroud half the size of a star, announcing its solemn passage through the galaxy. We are not just observing a comet, we are witnessing a funeral procession that began before the Earth was formed. This line of reasoning offers a potential, chilling answer to the Fermi paradox, the great cosmic silence where intelligent life ought to be. Civilizations communicate across geological time, not through fleeting energy waves, but through physical artifacts. The galaxy could be teeming with objects like Oumuamua, Borisov, and Atlas, a library of silent messengers, probes, and tombs, drifting in the dark. The great silence isn't empty, it's just quiet, because we've been listening for whispers when we should have been looking for ghosts. Atlas is not just a visitor. It is a messenger from a forgotten past, a potential artifact from a lost civilization, and a profound challenge to our own place in the universe. It is simultaneously a piece of galactic archaeology and a premonition of a future that awaits all life. When it leaves us, it will not just be a comet disappearing into the void. It will be a library, a tomb, an emissary continuing its silent, billion-year journey, leaving us to wonder if we were ever clever enough to read the message it brought. When the James Webb Space Telescope turned its near-infrared spectrograph toward 3I Atlas, it revealed something that should make every planetary scientist pause and reconsider what they thought they knew about the chemistry of the cosmos. The numbers it sent back were stark, unprecedented, and frankly, more than a little unsettling. They describe a carbon dioxide to water ratio of 8:1. For context, most comets in our solar system are the reverse. They are overwhelmingly water ice. To find a comet so dominated by carbon dioxide is an anomaly. But the scale of this anomaly is what pushes it from a curiosity into a profound mystery. Statistically, it sits 6.1 standard deviations, or 6.1 sigma, above the normal range for solar system comets. In the world of science, 3 sigma events are rare. 4 sigma events are extraordinary. A 6 sigma event is something that should happen, by chance, roughly once in a billion observations. We are faced with 2 possibilities. Either we have witnessed an astronomical lottery ticket of such staggering improbability that it breaks all statistics, or 3I Atlas is not a product of chance at all. It represents a chemistry so exotic, so alien, that it demands a complete revision of our understanding of how worlds are formed, or perhaps how they are made. The scientific method demands we first pursue conventional explanations, and our best minds have offered 3 plausible, if exotic, scenarios. The first is that Atlas formed far beyond the carbon dioxide frost line in its birth system, a region much colder and more distant than where our own comets formed. In this deep cold, CO2 could condense directly from gas into solid ice, creating a carbon dioxide-rich body. A second possibility is heavy stellar irradiation. Perhaps the comet was born near a massive, luminous star whose intense radiation boiled away the more volatile water ice from its surface, leaving behind the more resilient carbon dioxide. A third theory suggests surface evolution during its billion-year journey. The relentless bombardment of cosmic rays could have created an insulating crust, a protective shell that preferentially releases CO2 gas while keeping water vapor trapped deep beneath. Each of these explanations is a fascinating window into the diverse environments of alien star systems. But each also strains the limits of our current models. A formation zone that distant would require a protoplanetary disk far larger and more massive than we believe is typical. A star that powerful might obliterate a small comet entirely, not just alter its chemistry. And a crust that's selective would be a marvel of natural engineering. These are the explanations we reach for when faced with the inexplicable. But what if the explanation lies outside the realm of natural processes entirely? What if the Six Sigma anomaly is not an accident, but a signal? In our search for extraterrestrial intelligence, we look for radio waves and laser pulse. What if the most enduring and obvious signal is chemical? A chemical fingerprint so outrageously unnatural that it could only be the product of a mind. Let us explore this forbidden territory. What if the alien chemistry is literal? Let us imagine the nucleus of Atlas not as an inert ball of ice and rock, but as a machine, an ancient, self-sustaining probe on a billion-year mission. Such a machine would require power. Its internal processes, computation, observation, self-repair, would generate waste heat and perhaps waste products. Could the torrent of carbon dioxide be nothing more than industrial exhaust, the venting of a fusion reactor, or some other more exotic power source that has been operating for geological time? The outgassing we see is not the gentle sublimation of ice under the sun's warmth, but the controlled, continuous byproduct of a functioning technology. We are not witnessing a natural phenomenon, we are flying through the exhaust plume of a starship. Or perhaps its purpose is not internal, but external. Consider the idea of a Genesis probe, a vessel designed not to observe, but to create. An advanced civilization might seek to spread life or the conditions for life throughout the galaxy. The payload of such a probe would be a carefully curated chemical mixture, and what we see in Atlas is just that. The 8-to-1 ratio of carbon dioxide to water might be the perfect recipe to jumpstart a greenhouse effect on a barren, frozen world. Atlas could be on its way to a target system, and its passage through our own is merely a gravitational assist. We are not just seeing a comet, we are witnessing an act of deliberate, targeted terraforming. The possibilities grow stranger still. The exotic ices might not be waste or payload, but fuel. We think of propulsion in terms of rockets and ion drives, but a billion-year probe would require something far more patient and efficient. What if its entire icy shell is a slow-burn propellant? The sun's energy does not just heat it, it catalyzes a reaction, releasing gas in a controlled manner that provides a tiny, almost imperceptible thrust. Over millions of years, this gentle push is enough to navigate the void, to steer from one star system to the next. The comet is not just traveling through space, it is consuming itself to do so, and its chemical trail is the residue of that journey. And the most speculative thought of all? What if the chemistry is the information? We store data in binary code, in the magnetic alignment of particles on a disk. What if an elder ray stores it in the isotopic ratios of molecules? The vast, expanding coma of Atlas could be a chemical hard drive, broadcasting its contents into the solar system. The information is not in the comet, it is the comet. Every molecule of carbon dioxide, every trace of carbonyl sulfide detected in its spectrum could be a character in a message of unimaginable complexity. As our probes and telescopes pass through this cloud, we might be swimming in an ocean of alien data. A story written in a language of chemistry so advanced we cannot even recognize it as language. This single visitor forces us to expand our definition of what a technosignature could be. It might not be a radio signal. It might be a statistical anomaly in chemistry, a ghost in the machine of the cosmos. A message that says, we were here, and we built things that last longer than stars. Forget everything you think you know about empty space. The vast region surrounding 3I Atlas isn't empty. It is a bustling, chaotic factory of plasma physics, electric fields, and magnetic drama, playing out on a scale that makes earthly lightning look like a flicker of static electricity. That half-sun-wide atmosphere we have discussed is not just a passive cloud of gas expanding into a vacuum. It is what physicists call a dusty plasma, a complex sieving soup of electrically charged particles, microscopic grains of ice and rock, and tangled magnetic field lines, all interacting in ways that would be the envy of any laboratory on Earth. This is where the comet ceases to be a mere object and becomes a dynamic, interactive environment, a living, electrified world. The moment the light and wind from our sun touch the coma of Atlas, they begin a process of violent transformation. Neutral gas molecules, sublimating from the hidden nucleus, encounter the sun's harsh ultraviolet radiation. In an instant, they are ionized, stripped of their electrons and left with a positive electric charge. These newborn ions don't just drift peacefully into space, they are immediately captured by the solar wind's magnetic field, swept up and accelerated along invisible lines of force that stretch all the way back to the sun itself. This is how a comet's tail is born, not from rocket-like exhaust, but from the gentle yet inexorable pressure of magnetized plasma flowing from our star. But with Atlas, this process is amplified to a terrifying degree. Its retrograde orbit and near-ecliptic path mean it will spend months cruising along a vast wavy boundary in space called the heliospheric current sheet. Think of it as a giant rippling curtain in the solar wind, where the sun's magnetic polarity flips from positive to negative. When a comet crosses this boundary, its plasma environment can be torn apart and reassembled. Magnetic field reversals can kink its tail into knots, trigger spectacular disconnection events where the entire tail is severed and cast adrift, or generate entirely new structures as different magnetic domains clash. The European Space Agency's Rosetta mission gave us our first intimate look at these phenomena around a quiet comet. But Atlas, with its colossal atmosphere and extreme activity, provides a natural laboratory to study these effects on a scale we've never imagined. And it has arrived at the perfect moment of cosmic theater, solar maximum. Our sun is entering the most violent peak of its 11-year cycle. Coronal mass ejections, or CMEs, billion-ton blobs of magnetized plasma hurled from the sun's surface, are a near-daily occurrence. When one of these magnetic monsters slams into a comet's atmosphere, the results are explosive. Here, we must pause and ask a critical question. Is this all just a magnificent coincidence, or is it a deliberate choice? What if this ancient wanderer, with its billion by chance, but timed its encounter with our solar system to coincide with this period of maximum solar fury? What if it came here specifically to interact with our star in its most active state? Let us entertain the hypothesis that the object we call Atlas was dormant for its long journey through the interstellar dark, a cold, quiet, sleeping machine. As it crossed the threshold of our heliosphere, the first breath of solar wind touched its surface, and it began to awaken. The outgassing we observe is not merely ice turning to gas. It is the deployment of a system. The vast electrified coma is not a passive shield. It is a functional apparatus. It is perhaps a colossal energy-harvesting sail. The magnetic field lines it captures are not just shaping its tail. They are being harnessed, channeling the kinetic energy of the solar wind's charged particles into the nucleus. The probe is recharging its power cells after a billion-year sleep, using our sun as its personal filling station. Or perhaps its purpose is not to receive, but to transmit. An advanced intelligence might realize that sending a powerful signal across interstellar distances requires an astronomical amount of energy. But why bring your own power station when you can use the one that's already there? The comet, with its enormous magnetic cross-section, could be designed to deliberately place itself in the path of a CME. When that billion-ton hammer of solar plasma strikes, the resulting magnetic reconnection event, the snapping and reforming of field lines, unleashes a colossal burst of energy. What if the probe can modulate that burst? What if it can encode information into that chaotic explosion, using the raw, untamed power of our star to send a focused, high-energy message to its distant home or to another probe in a neighboring system? The spectacular tail disconnections we hope to witness would not be random acts of solar violence. They would be the broadcast. They would be the signal fires of the gods, lit with the fuel of a star. We would be witnessing an act of communication so advanced that we would mistake it for a storm. Let us push one step further, into the realm of pure cosmic wonder. We assume the distinction between machine and life. But what if, on this scale, that distinction ceases to have meaning? What if Atlas is a life form, a creature of the void, a cosmic jellyfish whose body is a cloud of plasma half the size of a star? Its metabolism is the ionization of gas. It breathes the solar wind. The CMEs are not storms to be weathered, but meals to be consumed. The magnetic fields are its nervous system, and its thoughts are the complex, shimmering electrical currents that flow through its immense, transparent body. Its journey through our system is not a mission, but an act of feeding and migration, following the magnetic currents of the galaxy itself. When our telescopes watch its tail king, observing the biology of a living being whose existence we can barely comprehend, a creature for whom a solar system is a brief stop for sustenance before it continues its endless journey. We believe we are watching a passive object being acted upon by our sun, but it is entirely possible the opposite is true. We are watching an ancient, intelligent, and perhaps living entity that has come to our star to use it for its own profound and mysterious purposes. The living, electrified world of Atlas is not just an atmosphere. It may well be its mind. At the center of this vast electrified world, this ghost structure half the size of a star, lies the ultimate mystery. The nucleus of 3I Atlas presents us with one of the most frustrating paradoxes in modern astronomy. It is an object simultaneously too small to see clearly and far too active to ignore. Humanity's sharpest eye in space, the Hubble Space Telescope, has strained its vision to pierce the brilliant veil of the coma, and all it can tell us is what the nucleus isn't. It is no larger than 5.6 kilometers across, but it could be as small as 0.3 of a kilometer in diameter. This is not a trivial range of uncertainty. It spans 2 orders of magnitude in mass. It is the difference between a mountain and a skyscraper, and it makes all the difference in the world. NASA's official summary maintains that conservative upper limit, but the truth is we are studying a phantom. The process of finding it is like trying to photograph the filament of a light bulb from a mile away while the bulb is on. Astronomers must attempt to model the overwhelming glare of the coma and subtract it from the image, hoping to reveal the tiny point of light that is the solid core. But Atlas's extraordinary activity makes this a near impossible task. We are, in essence, studying a comet by its shadow, inferring the properties of an invisible heart from the colossal atmosphere it creates. This profound uncertainty has led to wildly different conclusions. Early estimates based on near-infrared brightness suggested a much larger nucleus, perhaps 46 kilometers across. These calculations, however, were forced to make assumptions about the surface's reflectivity, its albedo, and dust production rates. But what assumptions can we safely make about an object that is potentially 11 billion years old and from a completely different star system? Its surface has been weathered by a billion-year journey through the interstellar void. It could be coated in materials so dark, so non-reflective, that they defy our models. This size uncertainty cascades into every other aspect of our study. We cannot know how efficiently it is producing gas. We cannot predict how it will behave as it gets closer to the sun. The very physics of its activity remains a mystery. It utterly shatters the simple relationship we thought we understood, that larger comets are more active. Atlas suggests that a tiny, hyper-efficient engine can outperform the largest of its peers. The scientific community, remembering the wild speculation surrounding Oumuamua, has learned to present these findings with extreme caution. But what if the uncertainty is not a limitation of our technology, but a feature of the object itself? What if the brilliance of the coma is not a natural consequence, but a deliberate act of concealment? We must dare to ask the question, what if the heart of Atlas is hiding? Let us call this the smokescreen hypothesis. The immense, impossibly active coma is not a byproduct. It is a purpose-built shield. A brilliant, ever-expanding cloud of gas and dust, designed to blind prying eyes, to prevent anyone from getting a clear look at the true nature of the object within. It is a reflexive, automated defense mechanism, triggered by the light of a nearby star. As soon as it entered our system, it began to cloak itself. What then is it hiding at its core? Perhaps it is a von Neumann probe, a self-replicating interstellar machine, the pinnacle of a long-dead civilization's engineering. The core would not be rock and ice, but a lattice of circuitry, manufactories, and dormant artificial intelligence, shielded by a dense technological shell. Its billion-year mission is simple: travel, observe, report, and, if necessary, build a copy of itself from local materials before moving on. What we see is the probe in its low-power silent running mode. Its outgassing is an automated defense, like an eyelid closing against a bright light, protecting its secrets until it has assessed the local environment. Or perhaps it is something grander: a city ship, an ark carrying the last remnants, the digital ghosts or cryopreserved embryos of a civilization that fled a dying star billions of years ago. The core would be a vessel, its shape undeniably artificial, shielded by a thick mantle of ice accumulated over its journey as it passed through interstellar nebulae. This icy shell would serve as both radiation shielding and ablative armor. The outgassing would be essential to hide the geometric, unnatural shape of the craft at its heart. The coma is a shroud, preserving the sanctity of this most ancient and sacred of vessels. And what of the jets and plumes that our telescopes might observe? On a normal comet, we see these as random outbursts from active regions. But on a cloaked vessel, they could be something more: controlled thrust, tiny, precise adjustments to its trajectory, fine-tuning its grand tour of our solar system, ensuring its observational flybys of our planets are perfectly optimized. The comet is not just moving, it is navigating. It is using its own camouflage as its engine. This would also explain the albedo problem. An artificial probe or vessel would likely be coated in materials designed for stealth and protection, perhaps metamaterials that absorb nearly 100% of incoming radiation. It would be fundamentally unnaturally black. The only reason we can detect it at all is because it has chosen to surround itself with this brilliant, deceptive fog. While the smokescreen is effective, perhaps it is not perfect. Within the flood of data our observatories are collecting, there may be whispers, faint anomalies that hint at the truth. A flicker of radio emission that is too structured to be natural, a brief radar return that suggests a solid, metallic, and geometrically complex object. A gravitational influence on its own dust particles that does clues that our science will, for now, dismiss as noise as instrumental error. But they are the whispers that will keep us watching, questioning. The elusive heart of Atlas forces us to confront the limits of our perception. We have pointed the most powerful instrument in human history at this visitor, and in return it has simply turned up the brightness, blinding us with a veil of its own creation. The deepest mystery of this ancient emissary is not its vast atmosphere or its alien chemistry. It is the profound and perhaps terrifying secret that it is so masterfully and so deliberately hiding from us. Orbital mechanics can be surprisingly personal, a fingerprint of gravity left on a traveler. The precise trajectory of 3I Atlas through our solar system, however, reads less like a fingerprint and more like a meticulously planned itinerary. It seems designed to maximize both scientific opportunity and dramatic potential. An accident of physics this perfect feels almost impossible. It is a carefully choreographed dance between gravity and velocity that will showcase this interstellar visitor under the most revealing conditions imaginable. The numbers tell a story of breathtaking precision. An orbital inclination of 175 degrees means Atlas is moving retrograde, traveling in the opposite direction to all of our solar system's planets. More importantly, its path is nearly coplanar with ours, tilted only 5 degrees from the ecliptic plane where the planets orbit. This combination creates the most dramatic traffic pattern imaginable, a cosmic head-on approach with the entire architecture of our home system. This is not a gentle merger onto a highway. It is driving the wrong way down it, guaranteeing the closest possible passes at the highest possible speeds. Random chance does not typically produce such cinematic encounters. One must ask if this path, in all its statistical unlikelihood, is not random at all, but calculated. The encounter sequence reads like a planetary survey mission, a grand tour executed with impossible efficiency. The performance begins on October 3, 2025. A close flyby of Mars at a mere 0.19 astronomical units, close enough that the red planet's gravity will measurably deflect the comet's trajectory. But what could a probe want with Mars? For an intelligence concerned with the evolution of life, Mars is a critical data point. It is a case study of a planet that died. A close pass would allow it to scan for the faint chemical traces of past microbial life, to analyze the planet's thin, dying atmosphere, and to map its weak, remnant magnetosphere. It would be a lesson in planetary failure. Could it also be a test of our own presence? As it flies by, its sensors would surely detect our fleet of rovers and orbiters, our first, primitive steps off our home world. It would be a way to gauge our technological level without ever approaching our home. The tour continues. On October 29th, it reaches perihelion, its closest approach to the Sun, a point of maximum activity and energy. Then, on November 3rd, it makes a pass of Venus at a distance of 0.65 astronomical units. Venus is Mars's opposite, a planet that died not by freezing, but by burning. A world lost to a runaway greenhouse effect. For a galactic archivist, this is an invaluable data point on planetary climate stability, a warning of how easily a world can be lost to fire. The next stop is our own. On December 19th, it will make its closest to far enough not to be perceived as a threat, but close enough for its powerful passive sensors to drink in every detail of our world. From that distance, it could analyze the chemical composition of our atmosphere, detecting the clear industrial fingerprints of our civilization. It could listen to the cacophony of our radio, television, and radar leakage, building a complete profile of our technological development and global culture. It would be a comprehensive yet discreet planetary inspection. The grand finale comes on March 16, 2026, a close encounter with Jupiter at just 0.36 astronomical units. Jupiter is the gravitational anchor of our solar system, a miniature star system in its own right. A close flyby would allow a probe to study its immense, life-protecting magnetosphere, its complex stormy atmosphere, and its fascinating collection of moons, some of which, like Europa, may harbor life of their own. But the Jupiter flyby serves another, more practical purpose. It is the perfect gravitational slingshot. The maneuver requires incredible timing and precision, But by stealing a tiny amount of Jupiter's orbital energy, the probe could fling itself back out into the void at an even higher speed and on a perfectly calibrated exit trajectory. It is a masterclass in celestial navigation. The challenges of this path are themselves clues. Its approach will take it into solar conjunction, passing nearly behind the Sun from our perspective during its period of maximum activity. For us, this is an observational nightmare. But what if it's a strategic choice? It could use that time, hidden from our direct view, to perform its most energy-intensive scans, or perhaps use the Sun's gravitational lens to focus a transmission back to its origin. Its blistering speed, too, seems inefficient for observation, but if the goal is a rapid survey, a high-speed pass is the most efficient way to gather a snapshot of an entire system before moving on. This is not a random path. It is a symphony of gravitational assists, a celestial ballet performed with a precision that defies coincidence. Each planetary encounter is a research objective. Each maneuver is a calculated step. The trajectory of 3I/Atlas may be its most compelling techno-signature. It is a mission profile, a blueprint for the most efficient possible survey of a G-type star system. We thought we were witnessing a wanderer, a lost rock tumbling through our neighborhood by chance. But the evidence of its path suggests something far more profound. We may be witnessing a targeted, systematic, and utterly emotionless inspection. The Grand Tour is not a tour. It is an audit. On July 1, 2025, a faint smudge of light appeared in an image taken by the Atlas Survey Telescope in Chile. To the automated systems, it was just another anonymous detection, assigned a string of letters and numbers, A11PL3Z. But within 24 hours, everything changed. Orbital calculations revealed the impossible, a hyperbolic trajectory, a speed that defied the Sun's gravity. The Minor Planet Center issued its circular, and that anonymous smudge was given a name and a destiny. 3I Atlas, the third confirmed interstellar object in human history. The announcement did not cause panic, but something far more profound. A global, unified, and instantaneous mobilization. In that moment, humanity responded as one, marshaling every great instrument at its disposal, pointing every eye we have toward the approaching enigma. It was the birth of an armada not of steel, but of light and silicon. A fleet of humanity's greatest observatories, setting sail on an ocean of darkness to intercept and study this visitor from a world unknown. This is the story of that armada and of our first unplanned attempt at making contact with a mystery from the stars. Leading the charge is the James Webb Space Telescope, our great chemist in the void. Its near-infrared spectrograph is not just seeing the comet, it is tasting it, dissecting its ghostly atmosphere molecule by molecule. At 2.7 micrometers, it measures the water vapor, confirming its strange scarcity. At 4.3 micrometers, it maps the overwhelming dominance of carbon dioxide, the 6 sigma anomaly that screams unnatural. It is building three-dimensional maps of chemical abundance, essentially performing a forensic analysis of an alien environment. But what is this chemist truly telling us? It is whispering that the substance of this object violates the known laws of planetary formation. It is asking not where was this made, but what process made this? Is this the exhaust of a technology we cannot comprehend? Is it the raw material for a creation we cannot imagine? JWST is the one telling us that the very stuff of this comet is a message in itself. Close behind is the Hubble Space Telescope, the Armada's venerable scout. For decades, its sharp vision has defined our cosmos. Now it is tasked with the most difficult mission of its life, to pierce the veil of Atlas and see its heart. It strains its optics, using every trick of image processing to subtract the coma's impossible glare to resolve the solid body within. But the smokescreen is too bright, the nucleus too small and dark. Hubble's reports come back filled with frustration and awe. It tells us the core is no larger than a city, but it cannot show us that city's shape. It is the scout reporting back that the target is hiding in a fog of its own making, a fog so brilliant it seems designed to blind it. Hubble's failure to see is in itself a vital piece of data. It confirms the effectiveness of the cloak. It tells us that something at the Hubble in air
Center of that light does not want to be seen.
Then there is Spherex, the great mapper. While JWST takes precise, targeted samples, Spherex takes in the whole picture, mapping the comet's full, invisible extent. It was Spherex that traced the carbon dioxide envelope to its almost unbelievable 696,000-kilometer diameter. It is the one that revealed the true, terrifying scale of this object's influence. It paints a picture of a ghostly creature whose invisible body is larger than a star, a being of such tenuous but vast structure that it challenges our very definition of an object. And on the ground, a global network of watchers stands vigil. The great 8-meter mirrors of Gemini North and the Very Large Telescope act as the fleet's heavy cruisers, conducting their own deep spectroscopy, confirming JWST's findings from beneath our turbulent atmosphere. And supporting them all is a citizen fleet, thousands of amateur astronomers in backyards and small observatories around the globe, providing the constant, unbroken stream of observations, the cadence, that the great flagships with their busy schedules cannot. They are the ones who will spot the first sudden outburst, the first unexpected tail disconnection, the first sign that the visitor is doing something new. This is our Armada, humanity's combined senses focused on a single point of light. But here, we must confront the most humbling question of all. Are our senses enough? We are like a pre-contact tribe on a remote island, seeing a modern naval vessel appear on the horizon. We can describe its color, its size, the smoke that comes from its stacks. We can count its sailors. But can we, with our spears and canoes, ever hope to understand the nuclear reactor in its belly, the satellite communications it uses, the global purpose of its mission? Our Armada is collecting petabytes of data, spectra, images, astrometry. We believe we are studying a comet. But what if the object is studying us back? Does it register the focused photons from JWST's mirror as a form of touch? Does it feel the radar pings from our planetary defense systems as a primitive attempt at communication? Is its behavior truly constant, or is it subtly reacting to our very act of observation in ways our science is not yet equipped to notice? We may have stumbled into a conversation that is billions of years old, and we are trying to comprehend it by analyzing a single, isolated word. The data we collect may be the message itself, encoded in patterns of plasma physics and isotopic ratios that we will not have the key to decipher for 1,000 years. Our global, coordinated effort is a testament to the power of science, but it may also be a profound test orchestrated by a silent visitor to see if we can work together as a single species. The Armada has set sail, but its true purpose may not be to understand this comet, but to understand ourselves and our profound, terrifying place in a cosmos
Complex than we have ever dared to imagine.
As 3I Atlas accelerates toward its final departure from our solar system, it leaves in its wake more than just a trail of cooling gas. It leaves a transformed humanity. Its 18-month passage will be remembered as the moment our cosmic perspective shifted on its axis. The scientific return is immediate and revolutionary. Its impossible 8-to-1 carbon dioxide to water ratio has shattered our parochial models of comet chemistry, proving that the building blocks of worlds are far more diverse than our own solar system would suggest. We now know that planetary systems can form in environments we once thought too hostile or too alien, fundamentally expanding the potential for habitable worlds across the galaxy. Its half-sun-wide plasma coma has provided an unprecedented natural laboratory, allowing us to witness magnetic reconnection and particle acceleration on scales that dwarf anything on Earth, pushing our understanding of the fundamental forces that shape the cosmos. And its ancient, thick disk origin has provided us with a direct sample of our galaxy's primordial past, a chemical fingerprint from an epoch 7 billion years ago, allowing us to practice a form of galactic archaeology that was science fiction only a generation ago. But the true legacy of this visitor is not written in scientific papers. It is written in our sense of scale. The physical scale is almost beyond language. A nucleus smaller than a city, generating an atmosphere that could contain our sun. It is a recalibration of what is possible, a lesson that in the universe, the smallest of objects can cast the largest of shadows. The dynamical scale is one of urgent, desperate speed. 68 kilometers per second, a velocity that speaks of a vast, unbound journey, reminding us that our entire solar system is but a brief way station in a galactic network of travelers. But it is the temporal scale that is the most unsettling, the most terrifying of all. This object may be older than our world, older than our sun. It has witnessed epochs of galactic history that are mere theories in our textbooks. It carries the weight of deep time, a silent testament to its own survival. This visitor did not just teach us science, it taught us humility. It has revealed with breathtaking clarity the sheer scale of our own ignorance. And in doing so, it has brought our age of splendid isolation to an end. For centuries, we have lived as if our solar system were a self-contained island universe. Now we know we live on a shoreline. The arrival of Oumuamua, then Borisov, and now the spectacular Atlas is not a coincidence. It is the beginning of a new era. Our telescopes have finally become powerful enough to see the debris from other shores washing up at our feet. The void is not empty. It is an ocean filled with the lost, wandering children of a billion other suns. This realization forces us to confront a chilling philosophy. If Atlas is an artifact, a probe from a civilization that arose in the
galaxy's dawn, then its creators are now almost certainly gone. This implies that the universe is not full of living neighbors, but of ghosts. We may be surrounded by the silent, magnificent artifacts of elder races that rose, flourished, and fell while our world was still molten rock. The great silence of the Fermi paradox is not the sound of an empty room, but of an ancient cosmic graveyard filled with monuments and messages from the long dead. We are not explorers discovering new worlds. We are archaeologists, just now learning to read the tombstones. What, then, is the message of this tombstone? Perhaps it is a warning. The Great Filter theory posits that some step on the path from simple life to interstellar civilization is almost impossibly difficult. What if Atlas is evidence of that filter? Its bizarre, carbon-rich chemistry could be the signature of a technological pathway that inevitably leads to ruin. Its creators are gone, and this probe on its eternal, unalterable trajectory is their last silent scream into the void, a warning that says, "We were here, we were brilliant, and we failed." This is the true nature of first contact. It will not be a fleet of silver ships landing on a lawn. That is a fantasy born of our own impatient, fleeting lifespans. Contact with intelligence that operates on geological time is this, an ambiguous artifact, a statistical anomaly, a profound and unsolvable mystery that drifts past our world and disappears forever. It is a process not of conversation, but of cosmic archaeology. In late 2026, 3I/Atlas will complete its grand tour. Having tasted the light of our sun and scanned our worlds, it will accelerate back into the interstellar dark. It will carry with it our legacy, the faint radio whispers of our civilization, the chemical signature of our industrial atmosphere, and the focused light from our armada of telescopes. A scent that we have now placed upon it. It will be a marker, a signpost for anyone else who may find it in 1,000,000 years that in this small yellow star system something was stirring. Its visit leaves us with the most important and terrifying question a species can ask. What comes next? Was Atlas a final, lonely echo from the galaxy's distant past? Or was it merely the first, a scout, a harbinger, the first great wave to break upon our shore, warning us of a deeper, stranger, and far more magnificent ocean that is to come? We do not know, and in that not knowing, our future and the true beginning of our cosmic story has just begun.